that his day job is a venture capitalist. So of course, this conversation, this chat, this address is going to be full of fun, a lot of knowledge. So grab your notepads and get ready for this next session with Professor Jonathan Fleming. Round of applause, please. Everybody's had lunch, some more energy.
So one of the first rules that you're given if you are somebody who speaks at conferences is don't be the first speaker after lunch. And so what I'm going to try to do in my brief talk is to stimulate you a little bit and get your blood going again and get you ready for some of the great sessions that are going to follow. The other thing I guess I would say is I always wanted to be an astronaut. And after having listened to Mike and Oleg, I still want to be an astronaut instead of what I am. And I want to thank the organizers not only for bringing me here to talk to you, but also for the opportunity to meet so many fabulous other speakers. So let's see if I can be up. I am. Let's see if I can make that work, and I can. So the first thing I wanted to do is just explain to you what I am doing here. So my journey actually begins in San Francisco. I'm the son of two hippies, and I was raised to make the world a better place. And it took me quite a bit of time to figure out exactly how to do that. Ultimately, I discovered the profession of venture capital. Venture capital is, I'm not the doctor, I'm not the scientist, I'm not the inventor, I'm not even the brilliant founders like some of the people that you saw this morning get up on stage. Really just the person who takes the ideas and the inventions of these people and organizes the right strategy, the right money, the right people to accomplish a specific task. And the beautiful thing about what I get to do is the ability to fulfill the injunction of my parents to make the world better, because the products and the services that these people develop that I work with, they save human lives. And many of them do fail, but in fact, those do succeed, and we have had a chance to save millions of lives with the products that have been invented over the last 30 or 40 years. I'm going to try to give you some inkling of what I think is going to come next. So this is a really important slide, only in that it symbolizes what's been happening in the world over the last 25 years. There's been a lot of talk about AI and about computation and obviously about the internet, but maybe the most important thing that happened now 35 years ago was the first sequencing of the human genome. For the very first time, we were able to actually decode the underlying source code of what it is that makes us human. That first effort cost the United States government $3 billion to do the first one. By the time we get to 2001, it's only going to cost us $100 million. Today, all of you can have your genome sequenced for hundreds of dollars. And the amount of data that will put into the system about how human beings function and operate, both when we're healthy and when we're sick, is going to be as big and important as any of the other things that we've talked about today. And here in India, just as I heard from the gentleman who came from Uber, that we need to put more data in the system, India needs to put a lot more energy into creating the capability of sequencing the genomes of Indians. This sequencing of the human genome, this explosion of medical knowledge has led to extraordinary accomplishments in healthcare, whether it's ability to find cures for HIV, for hepatitis C, for COVID. All of those things and many, many more have been a result of this explosion of scientific knowledge. And what it has done is it has lengthened our lives. When I came into this world, the average life expectancy for a boy like me, born in the 50s in the United States, was about 65 to 67 years of age. If that had stayed true, I would no longer be here by now. Instead, this explosion of scientific and medical knowledge has added 20 years on average, not just to my life, but to everyone's, because what this chart shows is that indeed this life expectancy increase is something that is happening all over the world. And my point to you today is that we can continue to add to that. We can actually add more additional years and decades to people's lives, even people alive today, and we don't have to invent any breakthrough new medicines to do it. The first thing that we have to do is that we just have to be able to use the medicines that we have today more effectively, to find the right medicine at the right time for the right patient. The second thing we have to do is take the medicines that we have and make sure they get out into the world so that the entire global population of the Earth can benefit from these advances and not just the people in the developed world. We need to focus a lot more on the prevention of disease. The cheapest way to prevent a disease or to cure a disease is not have it to occur in the first place. We need to focus a lot on getting humans to take better care of themselves. This is a field called behavioral health. Good luck with that. And we need to use technology to automate care. One of the most important things that's happened in the last few years in the field of medicine is the field of replacement parts. 4 years ago, I would not have been able to walk up these stairs to this podium because my knees were gone, essentially had no knees. Today, I stand before you with 2 knees that are made of titanium and that were printed by a 3D custom printer, and I can walk and run and chase my grandchildren like I was 40 years old. So one of the examples that I work on, the company is actually created by a Canadian Indian American out in Silicon Valley, takes the incredible complexity that we have today in treating cancer. Just to give you some idea, for solid tumors alone, there are over 246 drugs approved by the FDA to treat a patient. So if you are a doctor and you have a patient with cancer in front of you, you can do surgery, you can do radiation, you can do many different kinds of drugs. Which drug for which patient, under which circumstances, at which time? And this is a field where the promise of artificial intelligence is absolutely being realized, and these are products that are now being submitted to the FDA for approval. Robots are going to be incredibly important in the future in terms of getting care out of academic medical centers and into communities and homes where more advanced procedures can be done. This particular robot it's being developed in Boston out of MIT, and what it enables you to do is to put in a femoral line or a central line or an IV line in any setting done by any human anywhere. I myself, not a healthcare worker, have put a line into in this case it was a cadaver, using this robot. And so what this means is that instead of having to fly to Boston in order to have some advanced procedure, increasingly Boston will fly to you in the form of the robot. I mentioned screening and prevention. So there are 128,000 cases reported in India of cervical cancer every year. Last year, there were 78,000 reported deaths. By comparison, in the United States, about 1,000. Almost all of the deaths of these young women are preventable, just through better screening and prevention. And the little device in the bottom right hand is another robotic AI-powered device that I've been working on here in India, which we are going to deploy throughout the country in order to bring this kind of screening and prevention that you get by going to the most advanced OBGYN in Boston into the home or into the rural clinic here in India. So the next mountain that we have to climb in healthcare is the brain. Diseases of the brain are going to be the ones that really start to kill us more as we get better and better at treating cardiovascular disease or diabetes. And addiction is going to be one of the major problems, at least in the United States, that we are grappling with. We had over 100,000 deaths last year just from overdoses. depression, schizophrenia, Alzheimer's, Parkinson's, ALS. All of these are diseases that we are working on in the biotechnology and in the advanced medicine sector. But I have to say that we still have a very long journey in front of us. One of the areas where we do have incredible hope, and this hope comes directly from that first slide that I showed you about the cost of sequencing a human genome. So in the past, we have viewed diseases such as Alzheimer's or Parkinson's or ALS as a single disease. Like we used to say, you had cancer. Today, if a young woman presents to a doctor, we don't say that she has cancer. We would say that she has a lesion in her breast characterized by the following genomic signature, and we would qualify it and specify it in a number of important ways. And today, there are 9 primary different treatment paths to treat breast cancer. So when I was 6 years old, my mother passed away from metastatic breast cancer. If she got that diagnosis today, she would have a 93% chance, not just of being treated, but a complete cure. So taking that same approach of untangling a disease such as ALS and really understanding the different pathways, which different genetic mutations or different environmental pathogens start to create the cascade of disease, and treating them differently is going to be how we are going to unlock these diseases. And I am participating now in several global clinical trials with ALS patients where we're not trying to cure the entire population of ALS patients, but we have identified genetic subtypes of patients that we can cure. And we can cure them with these new genetic medicines that we develop in Boston. And we do have, for the very first time, genuine hope that getting an ALS diagnosis does not mean that you are not with us in 3 years. So this is maybe the most exciting area of the brain that I can talk about, because the others get a lot harder. Behavioral health is one of the hot topics in the United States. It's pretty much hard to go to any kind of healthcare conference or where people are talking about either the challenges in the healthcare system in the United States or things that people are working on. But we really do have, as humans, a need to grapple with the wiring of our brain and how it leads us into these addictions. So whether it is smoking or alcohol, whether it is drugs, whether it is gambling, something that is now legal in the United States, and we have a growing problem with addiction, or our addiction to our phones, which I also think have a very deleterious effect on your brain. All of these come under the rubric of behavioral health. And you are now seeing in the United States dedicated centers and communities that do nothing but treat these 5 things. People walk in with these addiction problems and try to get them treated. We have not had any success really developing new medicines against these addictions until very recently. And just by sort of observation, we have seen that patients who are on these GLP-1 drugs, these are the ones that help you lose the weight, turns out that patients on those drugs are also doing very, very well, not just in not eating, but in not smoking or not drinking or not gambling. I don't know about the phone thing. But the point is that there is now also some hope in a new medicine that is coming onto the market in these Ozempic and Wegovy meds and their competitors that I think is going to be very powerful. Hope for patients with PTSD. So I don't know if any of you have ever thought about what it's like to be a policeman or a firefighter or an ambulance driver, much less a soldier, and the kinds of horrific traumas that you have to deal with every day in your job. But those people get profoundly damaged. They have very bad PTSD, and until recently, there has not been any good way to treat them. Fortunately, and most of this work is actually being done in Canada, as opposed to the United States, there's now very carefully done clinical studies where we can show the benefits of psychedelics in helping patients who have profound disabilities from their trauma, from their PTSD, and their ability to return back to the workforce. The statistics in Canada are amazing in terms of their ability to return firefighters and policemen and soldiers back to the workforce as normal functioning people again, because they were able somehow to deal with this trauma in a way that they can manage it going forward. So just in conclusion, I know whether I'm involved with it as a venture capitalist or not, that we are going to continue to add years to our lives, and that it's certainly routine in my community to have people living into their 90s. It will soon be very routine for people to be living into their 100s. But let us all remember that a long life is not necessarily a happy life. And what are you going to do with all of this extra time that you have been given? And for me, a happy life is one that is filled with purpose, with some mission, some goals, some project where I get to work with brilliant people or committed people, dedicated people in a team, because humans do love to work in teams, and work on something that is going to save a human life and make the world a better place. I hope all of you here at NXT make the connections, to form the collaborations, to start those projects in each of these areas that we so desperately need new medicines. Thank you for your attention. So I think I'm being joined up here. I'm going to be told what happens next.
Thank you, sir, for that amazing session, and that, some of the things that you told us are completely groundbreaking and startling in terms of how simple and profound they are. Can I please request the arrangement team to put up 3 chairs? All right, at this point in time, Professor Jonathan Fleming continues to be with us.